Recently, NASA's James Webb Space Telescope revealed something extraordinary about an exoplanet called K218b, located 120 light-years from Earth. This planet, 8.6 times the mass of Earth, has long intrigued astronomers due to its location in the habitable zone of its star, where liquid water could exist. Webb's observations detected methane and carbon dioxide in K218b's atmosphere, molecules linked to life on Earth. Even more intriguing, scientists identified dimethyl sulfide, a compound typically produced by life on Earth, raising the possibility that K218b could harbor life beneath its hydrogen-rich atmosphere. This discovery marks an exciting step forward in our search for life beyond Earth. Humanity's curiosity about the cosmos has transcended centuries and civilizations. Whether through early philosophical musings or cutting-edge scientific exploration, we have always sought to answer one profound question. Are we alone in the universe? This question has inspired endless imagination, driven the relentless pursuit of knowledge, and shaped the course of human progress. It is a question so fundamental that it has spurred not only scientific inquiry but also profound cultural and philosophical reflection. In antiquity, Greek philosophers like Democritus and Epicurus proposed that the universe was not a unique, solitary place, but instead contained countless worlds, some potentially harboring life. Their reasoning was simple yet profound. If Earth, a single planet among the stars, could support life, then why couldn't other worlds? These early thinkers were among the first to challenge the anthropocentric view of the universe and recognize that life could exist elsewhere, perhaps under conditions similar to our own. Although their hypotheses remained speculative, these ideas laid the intellectual groundwork for the enduring human belief in the possibility of extraterrestrial life. However, for centuries, these hypotheses remained firmly in the realm of philosophy, as humans lacked the tools to observe the cosmos with any real precision. Without the technological means to peer beyond our immediate surroundings, such musings could not progress beyond intellectual curiosity. The invention of the telescope in the 17th century marked a turning point, revolutionizing our understanding of the universe. This tool opened humanity's eyes to a cosmos far larger and more complex than previously imagined. Scientists like Galileo Galilei used the telescope to unveil moons orbiting Jupiter, the phases of Venus, and countless stars in the Milky Way, suggesting that other planets and celestial bodies could very well harbor conditions conducive to life. These discoveries transform the question of extraterrestrial life from mere philosophical speculation into a scientific possibility, fueling a new age of inquiry. As science advanced, so did the scope of the question. In the mid-20th century, physicist Enrico Fermi famously asked, "Where is everyone?" This question encapsulates the Fermi Paradox. Given the vast number of stars and habitable planets in the universe, why have we found no definitive signs of extraterrestrial civilizations? Despite decades of searching, we have yet to detect any unambiguous signals or signs of intelligent extraterrestrial life. The Fermi Paradox has sparked an explosion of theories, each trying to reconcile this apparent contradiction. Some optimists suggest that intelligent civilizations are simply too far away for us to detect, or that they communicate using methods of communication we haven't yet discovered or developed, such as laser signals or quantum entanglement. These speculations have fueled projects aimed at detecting signals across a broader range of the electromagnetic spectrum, well beyond traditional radio waves. Others, however, are more pessimistic. Some theorists argue that advanced civilizations may self-destruct before achieving the technological means to communicate interstellar messages, due to internal conflicts, environmental destruction, or other existential threats. A compelling extension of this idea is the Great Filter hypothesis, which suggests that life, and particularly intelligent life, is so rare because civilizations rarely overcome the enormous challenges that lead to interstellar communication. Another possibility is that extraterrestrial civilizations deliberately avoid contact, viewing humanity as too primitive or potentially dangerous. This idea resonates with the zoo hypothesis, which proposes that extraterrestrials are intentionally observing Earth without interference, much like we observe animals in a zoo. The rationale behind this hypothesis is that more advanced civilizations may see our species as too immature or dangerous to engage with, choosing instead to monitor our progress from a safe distance. While the Fermi Paradox challenges our assumptions, it also fuels our determination to search for answers. The modern scientific pursuit of extraterrestrial intelligence began in earnest in the 20th century, as technological advancements made it increasingly feasible to search the cosmos for signs of alien life. In 1959, physicists Giuseppe Cocconi and Philip Morrison proposed that advanced civilizations might use radio waves to communicate across the vast distances of space. Inspired by their work, Frank Drake, an American radio astronomer, launched Project Ozma in 1960, using a radio telescope to listen for signals from nearby stars. Although no signals were detected, the project marked the beginning of a serious, systematic search for extraterrestrial intelligence, laying the groundwork for the SETI community. Drake's contributions did not stop there. In 1961, he formulated the Drake equation, a mathematical framework designed to estimate the number of active communicative civilizations in the Milky Way galaxy. The equation incorporates factors such as the rate of star formation, the fraction of stars with planets, the number of planets that could potentially support life, and the likelihood that life will evolve to intelligence. While many of the variables remain uncertain, the Drake equation provided a scientific basis for discussions about extraterrestrial life and set the stage for future SETI efforts. It has since become a symbol of the search for extraterrestrial intelligence and a starting point for anyone seeking to understand the probability of contact with alien civilizations. In addition to listening for signals, humanity has also attempted to communicate with potential extraterrestrial civilizations. One of the earliest and most iconic efforts was the Arecibo message, transmitted in 1974 from the Arecibo Observatory in Puerto Rico. This binary-coded radio message, designed by Frank Drake and Carl Sagan, was aimed at the M13 star cluster about 25,000 light-years away. The message contained basic information about humanity, Earth's location in the galaxy, our solar system, and even a simple visual representation of human figures. It was a bold and ambitious attempt to reach out to the unknown, a testament to the optimism and belief in the possibility of extraterrestrial life that characterized the space age. In parallel with these radio efforts, the 1970s saw the launch of humanity's most famous interstellar emissaries, the Pioneer and Voyager spacecraft. In 1972 and 1973, the Pioneer 10 and Pioneer 11 probes were launched, each carrying a plaque designed by Carl Sagan and Frank Drake. The plaque depicted a man and a woman, as well as a diagram of our solar system and Earth's location relative to nearby stars. These plaques were intended as a message to any extraterrestrial beings who might encounter the spacecraft, offering a glimpse of humanity's existence, our appearance, and our place in the cosmos. Building on the Pioneer plaques, the Voyager 1 and 2 spacecraft, launched in 1977, carried an even more ambitious message, the Voyager Golden Records. Curated by Carl Sagan and his team, these phonograph records were conceived as time capsules, intended to be discovered by any intelligent extraterrestrial civilization that might encounter them. The Golden Records included 115 images, greetings in 55 languages, sounds from Earth, such as a newborn baby's cry, a whale's song, and a child's laughter, and 90 minutes of music from composers like Bach, Beethoven, and Chuck Berry. Sagan described the records as a gift across the cosmos, a testament to the beauty and diversity of life on Earth, encapsulating the hopes and dreams of a species yearning to connect with the stars. While these spacefaring missions represented humanity's hope to reach distant civilizations, some potential signs of extraterrestrial contact have occurred closer to home. One of the most famous incidents in SETI history occurred in 1977 when astronomer Jerry R. Amon, working on a SETI project at Ohio State University, detected a mysterious 72-second radio signal from the constellation Sagittarius. The signal was so unusual that Amon famously wrote, "Wow," in the margins of his data printout. Despite repeated attempts, the signal has never been detected again, leaving it one of the most intriguing anomalies in the search for extraterrestrial life. In recent years, astronomers have been exploring alternative methods to detect extraterrestrial life, including studying exoplanets, planets orbiting stars outside our solar system. The discovery of thousands of exoplanets, many located in the so-called habitable zone of their stars, has significantly expanded the possibilities for finding alien life. One notable example is K218b, mentioned earlier in this video. Despite these advancements, not everyone supports the search for extraterrestrial intelligence. One prominent critic was the late physicist Stephen Hawking, who famously warned against actively contacting alien civilizations. In his 2010 book, The Grand Design, Hawking cautioned that if advanced civilizations exist, they might pose a threat to humanity. His reasoning was straightforward. In a universe with limited resources, a more advanced civilization could see Earth as a valuable asset to exploit, or even conquer. Hawking's concerns, shared by others like the late scientist and author Carl Sagan, emphasize the risks of broadcasting our presence to the cosmos. This worry is reflected in the dark forest hypothesis, popularized by Chinese author Liu Cixin in The Three-Body Problem. It suggests the universe is a dark forest, where every civilization stays silent and hidden to avoid detection by potentially hostile, more advanced species. The universe's silence, then, might not mean there's no other intelligent life, but could reflect a survival strategy, civilizations choosing to stay undetected. In this light, the absence of contact might be even more unsettling than finding aliens.